Hello, this is Kevin McDonald, Senior Systems Engineer with EMC Isilon. Today I will be demonstrating Isilon CloudPools to Microsoft Azure. Let me tell you a little about my test environment here. I'm running it on my laptop. It's using VMware Workstation, and I have 3 virtual machines I'll be using. First one here is IronForge. That is a Windows Server 2012 server running Active Directory, DNS, and also serves as my Windows client. Second one is Dark Portal. This is my Linux server where I'm running LDAP and also performs IP forwarding from the lab environment to the internet. Lastly, I have GNOME. GNOME is a single node Isilon cluster that I use to demonstrate CloudPools. It is running Isilon 1FS 8.0, which is required to use CloudPools. Okay, so let's go ahead and log into the web UI for GNOME. Okay. Okay, here is a single node cluster here. Now, Isilon CloudPools is implemented using the technology we call Smart Pools. It's a Isilon technology that allows the content of a file to move from one tier of storage on Isilon to another tier. A common use case may be data that is no longer accessed after a certain amount of time goes off of faster performing nodes to an archive node, for example. So if we look in File System Storage Pools, we have a tab in here now called Cloud Pools. And it's really simple to create a cloud pool. First, we need to set up a storage account. I will set this one up as Azure. The other options is Isilon RAN, which is leveraging another Isilon as the cloud pools target using the RAN protocol. Microsoft Azure, Amazon S3, and EMC ECS. ECS is Elastic Cloud Storage. It's EMC's cloud storage solution. For the URI, we will use my Microsoft connection to blob.core.windows.net with my credentials. And I need to copy my key over. I will be ignoring SSL certificates for the purpose of this demo. And I have now created that cloud account. It's that easy. Now to use it, you have to create a cloud pool. So a cloud pool could be called whatever you'd like. Call mine test pool. It's going to be Azure, and we are going to use the test Azure account that I've created. We have configured cloud pools. Now to use them, we need to implement a file pool policy. And this is the same as you would use with Smart Pools. Okay, here I will create a file pool policy, call it test Azure, and I'll put a file matching criteria on this for path contains /ifs /alliance, that is my access zone, /azure test. That is the directory in which I will be copying files to and leveraging file pool policies to move the contents of those files out to Microsoft Azure. We are going to move to cloud storage, and I will choose the test pool. I'm going to leave encrypt data and compress data selected. It's a best practice. If you're storing your data out in a cloud, you'll want it to be encrypted and you'll want it to be compressed for best cost savings. Under the advanced options, there's one noteworthy to point out, and that's this cache expiration here. When we recall data from the cloud, when users access them through Windows Explorer or whatnot, or their application, we will pull it back from Microsoft Azure and store it locally on the Isilon on disk. And after 1 day, that will expire. That's important from a performance perspective. If your users pull back a file from a year ago, that's an Excel spreadsheet that they're interested in, they may have interest for a whole day to look at that file, and it's best from a performance perspective to have that cached. Creating that policy, and there it is. We have a file pool policy. It is that simple from the web UI. Now looking out here from a Unix perspective, I am in the IFS Alliance Azure test directory, and there are no files. So let's copy some files there. let's do it from Windows. So let's see, Windows Explorer. I have some files and documents here. Let me grab a couple of these files. And I already have this share mapped to my Z drive, and here is Azure Test. I will paste those files there, and from a Windows user perspective, there is no difference in copying these files to the Isilon share as they would have today. Looking at the content of the files, one is 657K and the other one is 2.6 meg on the Isilon cluster today. Now, nothing has happened to move that data to CloudPools yet. There is a job engine dedicated to CloudPools that manages that entire construct. Looking at my last job run here, you can see where I archived some data, a couple files here, and they were successful. We need to go ahead and force those files to be archived off so we can watch it happen. So I will do an Izzy archive, Izzy Cloud archive on these files. Looking at the job engine now, we can see that we have 2 files in a pending state. Now we have 1 file pending, 1 in progress. Now we have 2 files succeeded, and they are now stored in the cloud. Looking at the files here from a Unix perspective, we now have 8.5K stubs for both of these files. So from a storage perspective on the Isilon, they're only consuming 8.5K. Now if we go look out in the cloud and see what we have here, we will see our objects. So I'm using CyberDuck. CyberDuck is an open source utility where you can go and look at cloud environments and the objects in them. Now I've run this test a few times, so I have multiple containers out here. The D containers, that contains your cloud data object. These are the objects that are stored out in the cloud. The M containers, this is your metadata object. We store metadata out there about those objects for future use. As you can see, it created 4 objects for us of these small sizes. The max you will see these objects get is 1 meg. So if you have a 1 gig file that you archive out, you're going to have 1024 1 meg objects. That's just the best efficient way to store data in an object repository. So let's go ahead and copy these files and paste them. So the Isilon has to recall them from Microsoft Azure and then serve them back to this Windows client. From a Windows perspective, it looks like you just copied files. It took a little longer than normal, but that's all that it appeared. From an Isilon perspective, we have something interesting that happens. We no longer have an 8.5K file, an 8.5K stub like we had before. We have 2.6 megs because we had to recall all that data from Microsoft Azure, store it on disk on the Isilon, and serve it to the client. So it pulled back more than was there before because we had to cache them there. Now if we wait a day, this will eventually expire and go back down to the 8.5K stubs. Let's go ahead and force an archive on these pieces, on these files, and take a look at them. Nothing's changed yet because we've got to look at our job engine. Here we have 2 new files in a pending state. Still pending. 1 is pending, 1's in progress. 1's in progress, and they have succeeded. So we had just archived 2 more files, those new copies, out to Microsoft Azure. If we take a look at these files from a Unix perspective, the 2 copies are now 8.5K stubs, and the other files are still inflated because we're waiting for 24 hours for that cache to expire. From a Windows client perspective, these files are still out here. Okay, so the other option I can show you is a recall. So we could do an Izzy Cloud recall on, I'll do it on star. So basically what I'm saying is bring all these files back from the cloud and store them locally if you have such a need. So we have 4 files in a pending state. We now have 2 in progress, and we have succeeded. And that was a recall command saying, hey, I want all these files no longer in Microsoft Azure. Put them back on my Isilon for whatever purpose you may have. So if we take a look at the size of these files, they should be, they're full size. And they are. As you see, we have 2 657K files and 2 2.6 meg files. You can also delete these files. They are now gone. Come out here on the Unix side, they are gone. Now, if we go look in CyberDuck here, quack, quack, pulling it up, we will still have these objects out here because there's a garbage collection function that has to run and clean up these files. Sorry, these objects. That's important because we could have snapshotting occurring on the Isilon. In this case, I don't have it configured, but there could be snapshots that still point to these old objects and may need them to reconstruct files. So garbage collection is out of band and runs as needed as part of the Isilon CloudPools job engine. That ends my demonstration. I hope that was useful, and I will be doing more as time allows. Thank you.